All right. Isopropyl alcohol. You guys probably have this at home. Yeah. It's 70% isopropyl alcohol. What's the other 30%?
Water.
Water. And I'm just going to pour it in the speaker and take a look at it and tell me whether it's a homogeneous or heterogeneous mixture. Sort of an easy question. Why homo? It's a solid.
I mean,
Okay. We are doing this for the honors class, but don't play dumb on purpose.
It's the same throughout.
It's the same throughout. We have what, one layer, right? One phase, and so it's homogeneous. And I have just a piece of an old cotton T-shirt. And isopropyl alcohol is flammable. So of course, with flammable things, what would you like to do? Burn them. And so we have a Bunsen burner here. You guys know how to use these. We'll get this ready. And we'll just wring a little bit of the isopropyl alcohol water mixture from the shirt. And we'll light it on fire. And then of course as it burns, just make to what I would think would be a pretty obvious observation.
table's on fire.
Besides the table. The table is burning. Okay. I guess I could do it over the floor, and then you'd say, well, the floor is on fire, so we'll just leave it here. Maybe it's not quite so obvious. Look.
It's not burning.
It's not burning.
It's not burning. Come stick your hand here in the flames and then tell me it's not burning.
I'll dip it in the alcohol first.
What's not burning?
Sure.
Yeah, the cotton cloth is not burning.
Oh, now it is.
The little part is.
I might get a little bit.
It is.
Yeah, it's burning. It's really burning.
Yeah,
I guess I didn't have enough water. There's a reason if I run out of moisture, we'll talk about why. Okay, if we to feel the cloth right now, besides being a little bit warm, it's almost completely dry, isn't it? I mean, it's pretty close to being completely dry. The reason that this part burned was because it did end up getting completely dried. And of course, the reason for that relates to that swimming pool story that we've told before in sort of a weird way. When you get out of a pool on a hot summer day, it might be 100 degrees outside, but when you get out of the pool, what do you start doing? Feel cold? You start shivering, your lips turn blue, you get goosebumps all over your body. But it's still 100 degrees outside. So why do you get so cold?
It's water evaporates.
You have a liquid evaporating, don't you? And evaporation is what type of process? It's a cooling process. So can we relate that to this rag? Was this rag moist with alcohol and water mixed together?
Yeah.
And so we got a lot of heat from the burning alcohol, but a lot of that heat, of course, it was released to the surroundings, but this moist rag was also part of the surroundings. So a lot of that heat energy went into doing what? Evaporating the liquid, either the isopropyl alcohol, which didn't take as much energy as the water. And I wonder if perhaps, so maybe having a 70% alcohol and water mixture, I wonder if I bumped it up to maybe a 60 or 50%, wouldn't I have more water in here that wouldn't be burning, which could absorb more of the heat and maybe cause it not to do that? Okay, so just keep in mind there's an exothermic process happening there when it burns, and then an endothermic process occurring as we evaporate that water and the alcohol.